this different type of phenomena coming as a start from the permafrost is fantastic, actually, when you look into the freezing process, because the Palsas is then frozen soil. I was not studying these things before I came up here to this high north, so I only have the knowledge of the Palsa for the last 20 years. But what you actually see here is the Palsas. I'm sorry, my throat is a little bit bad because I got a flu, so I'm not very nice in voice. Palsas, palsa, palso, these Polish names and these Icelandic names, but all of these palsa came from the Sami word palsa. So palsa is the origin for the Palsas. Usually, most countries use this word for this phenomenon. What you see here, it is actually a string of Palsas, a string Palsa. This is 3 separate Palsas, which is connected together into a string. If you see here, you see the turf, and then here you see the water level, and here is the marsh, which is more bushes, but most of the Palsas is made from peat, from the Svagnum, the torf types. So most Palsas is on a flat terrain, a flat land, but it can also occur in, there's a small slope or something, then that is even possible. But mainly they're found on the flat mires. And the reason for this is the water level. We'll come back to this later on. So here you see Palsas, here you see the torf. This is underneath, this is the accumulated Svagnum or peat or torfs through different ages. So it can be like a few hundred years to several thousand years old. The Palsas are found basically in Fennoscandia, in Iceland, Greenland, Russia, Central and Eastern Asia, Canada, and Northern USA. But also somewhere in the Alpine zone and in the central part of Europe, like in Germany and also in the Carpaths. So this is not only in the high north, but it also have a few places in the Central Europe. But also in addition, there is Palsas in Southern Hemisphere, in South America. The Palsas is, like I said, the first step to the permafrost. So the Palsas is never melting normally, but they might die, they may melt, or they may become born, so they can develop into new Palsas. And the Palsas is dynamic, it's not a stable thing, it's pulsing, it's working and responding onto the climate. So the differences in the climate will make changes of the Palsa. On this picture, you see the different indications of permafrost, and here you see continuous, the darkest one, dark color, and then the second dark is then the area where you can basically find the Palsas, but also where you have sporadic permafrost, this can be a Palsa area. However, it is not a very big areas when you're looking into the European part, but in the Asian part of Russia and the US and the North America continent and Greenland, this is quite big areas, which is potential Palsa and where you can actually find the Palsas. So here is a map where you can see on the Fennoscandia where the Palsas are distributed. So some in Finland, a little bit into the most part of northernmost part of Russia here, but basically all on the eastern side of the Kola Peninsula, which is over here. Sweden, and then down in south of Norway, and also a couple of places in the middle of Sweden. The palsas are basically born as a small part of ice, which is collected during or growing during the winter. So in my outside area here, normally we have 60 to 70, 80 centimeter of frost every year, which is melting. Sometimes this ice in the mires may be continuing frozen during the summer. This because of the climate, but also because of the heaviness of freezing, and then also above the insulation of the turf. So the turf, the sphagnum mass, which is here, this is the sphagnum mass which is here. This is then making an insulation so the ice is not melting. During a few periods, some years, some decades, the palsas will grow, and this can happen quite quick, or it can be a little bit slower. But then it expands, getting bigger. And then to make it as a palsa, it needs to have contact. So here you have the water surface or the top of the mire, which is basically wet. Down here you have the peat, and then in this part here, this is the silt, the ground under the mire. Usually this is not very thick, but a few meters. So normally in the palsas in the area here in the north, this is about 1 to 2 meters deep. But in other places you might find it much more deeper, like tens of meters. But normally it is not so, because one very important thing is that these ice lands need to have contact to the bottom in the end, to start to rise, to start to grow high above the level of the mire. So what happens? The palsa is freezing into the ground, and then also having this ice here, which is then water and the peat. What is important with the water level here is then giving the nutrient, in a way, the nutrient for the new ice. So there's a mechanisms of going ice and water here, which go into and turn into ice, and then the pulse top can slowly grow up. This also means that in the palsas, this bottom is moving a little bit, in a way moving. It's freezing, actually. It's freezing up. So you get minerals, sand and silt from the bottom, freezing up through the ice during the centuries. So this is actually our mechanisms of changing, transfer of ground substrate like sand and small stones and silt from the bottom of the mire up to the surface. This can happen in different ways. This is up here, some drawings which have been borrowed from Hofgaard. So this, to remember this, the layer of the water is important, and the depth of the peat, and then it cannot be very clay, it cannot be very good drainage, so it needs to be a type of this silt type, which is the basic for the sediment underneath the palsas. So therefore they cannot develop everywhere where you have peat mires. This fundament to the ground may be the reason also why these can grow high up into the air. So they can grow like 5 or even 10 meters tall. Here is a picture of a palsa which is starting to die. So this then normally this pounds the pulse plug. The pulse plug here is the water is getting bigger, and then the palsa is missing some of the peats which is should be there to make the insulation, and then there's an erosion, a melting process during the summers. And also you see here on the top here, the top is crackling, it's dividing into, and then it's falling off, like you saw on the other former picture where you saw the black soil, the peat, black peat, brown peat. In the end, the palsa will then melt, and then the sand will stay under, or the clay will stay underneath. So it's getting a smaller or ground pound. Okay. Did you understand this? I hope so. So here you see some pictures. So we use this type of core to make a sample to see how the palsas. If you look very careful here, you will see this is a little bit frozen peat. You will see the small crystals in between. Here you see different depth. This is actually the deepest, and this is the top of the frozen land, frozen peat on the palsa. So normally the turf that you saw on the top layer, which is here, and this one is not frozen. This may be only like 30 centimeter to half a meter thick. So because it needs only to be 20 centimeter like this to be perfectly insulating through the whole summer, even if it is 30 degrees warm in air. And the sun temperature may be even warmer. Just outside now we have nice blue weather and blue sky, and the temperature on my wall outside is 45 degrees, even though the temperature in the area outside now is like 11. So the effect of the sun and the temperature makes these things to crack, but the thickness is then telling about how good it is insulated. So further down you will see like this. This is like a frost, permanent ice, which is inside in the palsa. Which is in between the different type of small roots from the small birch, the betulanana, this dwarf birch, and other type of small bushes, salix, basically. This is an iron core that has been driven into the bottom of the palsa. Here you see the ice, and here you see the silt. It's very fine sand, which is very close to clay. So it is to make the silt. It is eroded through the glacier periods and such, and then this sediment is then mixed with the water to get the right fraction, combination of this size of the particles. So this silt is then something which has been developed in the end of the glacier period. So here you see such a palsa, which is one small hump, a couple of 1.5 meter approximately. And here you see the crackulations, and inside here it is ice. So the ice is something like this inside. So from Wikipedia, you see this type of palsas. I just borrowed this picture just to show, because it's very nice up. And here you see this pulse plug, the pulse pounds around, which is then telling about the wind directions, where the palsa is developing. And here you see some very destroyed palsas as well. And this is a dead palsa. Here is a part of a palsa which is dying. So this probably has been a palsa earlier. The palsas is having a lot of different shapes, like you see here on this picture. In addition, there is also micro palsas, being very small palsas, a few meters only, maybe only 50 centimeters tall, but under the mire, it might be about a meter of ice length. So here you see some other picture of palsas. You see palsas up here, different ages. Here they are, this craculation, they are destroyed, getting falling apart, and also here. So this has been big palsas that have been falling apart. You see how this system is working with the erosion of them. And you can also, to some extent, see how they have been, where they are developing. Because on the side, they can die on one side, and then they develop the other direction, the other side of them. Then they will move in a way, they will freeze forward or to different directions. And then this is making this type of strings or different complexes, which was said on the other slide. So here you see the pulse lag, the small pulse pound. And this is very important because this tells about the level of the water. Here you see close to this pond, this has been a palsa earlier around on the back side of this man. But today it's only this which is a part of a palsa. And here you see this palsa is eroded away. It's dying. So it's dying in this direction just now. So when this is falling down, then we can understand, together with this pulse lag, this pond, we understand that the palsa is having a problem on this side. In the end, it will turn like these things. There will be a pond, but after a while, the pond will be covered by the mosses, and then it will just look like another part of the mire again. So this is an area where there have been a palsa once. You see a small part of a small palsa under this marker now. I hope you understand this, that I'm not telling. So this is how the ground is looking. So between here you see some cloudberries and different species, and you see the mosses here. So the mosses is then making the main substrate for the development of the palsas. Sorry, I apologize. I'm sorry, there's the shifting of the slides is going a little bit slowly, therefore it's not working fully. That's why I'm making so late. So here you see another mire, and here you see a small hump. This may be even a palsa. So and we can check, because if this is only peat or mosses, and then here you find this frozen part of the palsa inside, then it is also, when it's old, this make a little bit of silt into the ice here. So you see, silt is the material of size between sand and clay. And this is because of the sediment from the erosions during the glacier period, which is then mixed with water and then falling down very nicely. So palsas and silt is combined. The palsa need basically treating together with the silt and together with the peat. It need only maybe as little as possible of water, of snow or rain as precipitation. Often they need less than 600 millimeters. So if the amount of rain is going very much up, and also much with the snow, then it will be killed. But it depends when it is raining or snowing through the year. If it is raining in the cold period in autumn, this can be not so big problem for the palsa. But the problem is if it is raining a lot in the summer, because then the water is not getting warm, but it is lifting up the ice. So the ice is getting a little bit shaken, so to say. So this makes that the ice is floating, of course, and then it loses contact from the ground, and then water will come underneath, and then it will be not connected to the ground, to the silt anymore. If it is getting too much snow, then the snow will insulate through the winter, so the temperature is not able to make good freezing into the palsa. What is important, because the palsas is on the mires, and then you have wind, and then the snow layer is usually flat. So when you have the palsas coming up, then the top of them will be blown clear, so the mosses will be into the air directly, so they will not be covered, just like you see here on this stone ground small hills here. Then the top of them will be naked, and then the frost is really working when you have minus 35 degrees or minus 30 degrees for 2 or 3 weeks. Then the temperature will work as a perfect freezing through the winter, which is then lasting through the summer when it's not melting. So if it gets too much snow, then the palsa will be insulated, so they will not be able to freeze properly. So little precipitation, we need the wind, and we need the temperature. And this is a little bit complicated when you have usually in the continental part of the northern, when you have cold temperature, the wind is not blowing. There are some mechanisms like where the meteorologist will tell you this on other lectures I have seen. So, okay. If I now get, so here you see a palsa. So usually the wind direction goes like this, and then you will have this pulse lug, this pond here, because this is the water level going through here, and then you see the turf is falling off, and here is the ice, frozen material in the center. This is the bottom. If the wind is blowing like this, the snow will lay like this. And then what happened here? This is, of course, it's insulated in the summer, depends a little bit. But remember, in the north, we have midnight sun. So now there is midnight sun all the day, all the night. So it's 20. If the sky is blue, we have 24 hours of sun. So the sun works from every direction, from north, from south, from east, from west. That is one of the beautiful things about being north of the polar circle. The sun has a total different meaning for the ecosystems compared to the south. But you see here, this part is then open, which is also making it a little bit more fragile, vulnerable to wind, because the wind is not letting the snow to cover this, and then the wind will make shaking, and then together with the drying, this will kill the layer of the moss which is on this top. This part will not freeze so very well. This will be the one that is freezing the best, but it will have a problem during the summer. So then it will start melting when this is falling apart. So especially if this is towards the south during the spring, this is the first part that will be melting. I will see if I manage this. Yeah. If the getting more snow, then it will be something like this. If it's getting less snow, then it will be something like this. It was not so very easy to draw, but then there will be less cover. That's the point. Sorry. If the snow is wind is changing, for example here, I will see if I can make this. Oh. Yeah, it worked. So if the wind is turning to blow this way, then this will start open. Then the snow will be low here and up and big here. So then this part will be more exposed when the wind direction is turning. So this makes that also the wind will make the different part of the palsa, when you look at it from the top, it can be moving or changing in different directions, depending on the wind which is exposing the top of the palsa and the side of the palsas. So when was this palsas made? Some of them is very old and some of them is quite young actually. In Fennoscandia, there was mainly 3 periods of making palsas. So there was one period about 4,000, 3,000 years ago, just after this other period, this very warm period. So about 6,000 years ago, it was very, very warm. And it's believed that none of the palsa did never exist here during that period. But in this period, the palsas are starting to grow and to develop. And there was one period about 700 years ago, about 1300, and there was also the Little Ice Age, which was from 1590 to 1750, about 400 to 250 years ago. That was the main periods where you can see. So we have 3 periods of ages of palsas. One which is 4,000 years ago, and one which is 700 years ago, and one which is about 300 years ago. But even about 1900, 1904, it was a very, very cold period here, and several palsas was made in this period. And lately, in 1960s, and also into the beginning of 1970s, there have been made new palsas. The size of the palsa varies. Some places they grow extremely quick, and other places they're growing very, very slowly and not much development, not depending on the age. The palsas in Central Europe, Germany and Romania are basically all relict. They are pieces of palsas during the glacial period. They are very, very rare. They are very, very vulnerable, and they are just about to disappear. So in these ones, this is very, very seldom to find. But you can find the type of pounds and this type of special substrate that you can tell that there have been palsas. In Siberia, the palsas is very, very much more older usually. Several tens of thousands of years. But this depends quite a lot as well. So it's very important to remember that this is outside of the normal permafrost area. So this is where you have permafrost in just small patches, small areas, which is this. So here you see this pulse lag, and here you see the turf, which is breaking off and falling down. So then the palsa is dying off in this towards that direction. This is palsas from close to Siberia. It's close to Enrol mountains. You see even the houses of the cities, which is behind, is built upon the permafrost and the palsas. You see scientists working. So in this area, here you see we are digging through about 60, 70, 80 centimeters, and then the upper 50 centimeter is not frozen, but there you see the frost in this layer here. This is also palsas. It does not look very easily to understand that this is a palsas. This is a plateau palsa, which was mentioned on one of the earlier slides. So this is some of the tools we are using, different type of core takers and drills and songs to make a sampling of the palsas, to investigate the palsas. So drilling down a little bit through the torf and into the ice, and then also making the samples in the pounds to see how the pulse lags has been developed. So this is on a palsa, making sample and to investigate the age of the palsa, which is done by carbon aging. You will hear more about this from other lectures, I guess, later on. But that digging holes, basically. So this is scientists talking a lot and discussing everything which we are seeing. and try to understand what we are really seeing and discussing. The reason why we are putting this onto our plastic is to put the palsa, the peat, back into the palsa, so we protect the palsa from melting. So in this palsa, it's about 0.5 meter. This is centimeters, and then this 0.5 meter. So we make a lot of sampling and photos and everything to record. And if you look carefully, you will see different colors. You see this? So the different colors tells about the different epochs of the different type of peat that has been developed. Because some of the peat is from below when the palsa was born and then shuffled up or pushed up. And some of this is actually peat which has been developed after the palsa was made from the top, which is the mosses which is today growing there on the top. And then after a while they get pressed down and then they become this part of the peat which is inside. So just to show you such, so then making the sampling here, you see taking the samples, then we can analyze the different type of the species of mosses and other plants, and also we can see on the different colors and the different type of structures, and then we can understand the age and how the palsa was made and what is the processes behind this. So here you see a slice of palsas and of the peat of the palsa. So you see the moss here, but this makes 3 different layers. It's telling different part of the different histories. So here you see a dead palsa area. Today the palsas is threatened basically by climate, but also by humans. So when people is making ditches into the water, into the mire, the water is lowered or raised, and this makes the effect on the palsa, on the ice. If the water falls too much, then there will be not enough to the freezing process to make the from underneath. And if it's getting too much, then the palsa will melt away. So this process is also the process of putting trees, different trees into the making forestry on the mires, make a threat to the palsas. Here you see the palsas in the background, and this is a pound, or this was a pound from the palsas, which is this pulse lug. And here you see this cotton wool, which is a little bit red. It is actually a red cotton grass, cotton sedge, cotton wool, Eriphorium rosoleum. Very nice, isn't it? This is often found in connection to the palsas. Different birds use the palsas because they can sit on the top on the mire, and they can make playing, and they can watch after predators, so they can be a little bit more safe if they are close to the top of the hills. Also, the predators like the big owls and the falcons use the top of the palsas to sit, and then they are shitting or they are vomiting the remnants of the small mice and these things, like the bones and the hair and such. So on the top of the palsas, you also find the parts of the fauna which is around. And also, just showing this also is found quite commonly to the mires where you have the palsas. This is this type of moss. This is named parasol moss. It's a special moss because it's basically only growing on the shit, on the feces, on the pew from moose and reindeers. So here there is some shit, and then the mosses is specialized to grow upon this facies. Sorry, I apologize. There's also other species which is totally connected, like this Epilobium lavastadi and this carex, which is basically only found close to the palsas or the palsa ecosystems. And also, like this berries, these are the cloudberries. This is a very important part into people and people's life. So in history, people have been collecting these on the mires. And actually the palsa, as you remember, is cold inside, it's frozen. So from Stone Age up, the people has been using the palsas as refrigerators. So they took away a little piece of the peat, and then they put like these berries or meat or fish into the palsa and put back the peat on top of them, and then it could be there until the winter came. So that was they used the palsas for the storing of the food. So palsas is protected in all Europe because it's a priority nature type that is heavily vulnerable, which is very, very close to extinction in most part of Europe except the high north. But even here in the high north, they are disappearing. So basically 80% of the palsas in Fennoscandia is diminishing, is getting smaller, 80%. Only 20% is stable, and only a few percent is actually growing. So therefore, it is a problem. It's in my part of Finnmark here, we have 3,000 palsas approximately. But I don't give a big area. It's something like 500 hectares, which is palsas, calculated to be palsas. 500 hectares, not much. Okay, good folks. I hope you had some news, heard some news, and it was not too complicated. I'm sorry. But you will find more on the internet, and you can find more on the Polarpedia pages.